Hello, welcome to our last or third lesson under logic, the truth tables. The truth value of a simple statement is either true, or that's T, or false, or represented by F. The truth value of a compounded statement depends on the truth values of its simple statements and its connectives. A truth table is a table that shows the truth value of a compounded statement for all possible truth values of its simple statements. We will have some examples in the next slides. Let us now familiarize ourselves with the truth values of the five logical connectives. Let's have negation. For negation, if the given statement P is true, the negation is false. And if the given truth value for P is false, the negation is true. Okay, so you need to memorize that simple table for the truth value or truth tables for negation. For conjunction, we need two statements here. They are denoted by P and Q. Okay, and if both statements are true, the conjunction P and Q is true. If P is true and the other one is false, the conjunction is false. And if P is false and Q is true, the conjunction is false. And if both statements are actually false, the conjunction is false. So as you can see for the conjunction, there's only one possibility that it will be true if both statements are true. All other combinations for the truth values of P and Q, the conjunction will be false. So it's only true if both statements are true. That's for conjunction. Let's proceed to disjunction. So for disjunction, we also need two statements and we use P and Q here. Okay, and as you can see, all can be true with these combinations, but there will be only one possibility that it will be false. That is if P and Q are both false. So if at least one is actually true among the or of the two statements, at least one is true, the disjunction is true. But if both are false, the disjunction is false. So as easy as that. Okay, let's proceed to the conditional statement. So for conditional, we also need two statements, P and Q here. And then here are the possibilities of the truth values of P and Q. And as you can see, there's also one possibility that it will be false for conditional statement if our first statement is true and the second statement is false. That is if T then F. Okay, so TF. So you just memorize talent fee or TF, that will be false. But if it's FT, it will be true. Okay, so that's how to maybe memorize this table for conditional statement. And let's proceed to biconditional. So for biconditional, as you can see, there are two possibilities that it can be true and also two possibilities that it can be false. It is true if both statements are true, and it is also true if both statements are false. So if one statement is false, then if and only if another false statement, that becomes a true statement. But if we have the first statement as true, the second is false, it will be false. And if we have the first statement as false and the second statement is true, that will be false. So you need to memorize this table, okay, in order for you later on to find the truth value of a given compound statements. We will have an example of this in the next slide. Okay, so let us consider the following statements. SPUP is a Catholic university. SPUP is in the city of Ilagan. SPUP is the only private university in the region or in region 2. And S, SPUP is an ISO certified institution. Determine the truth value of the following statement in symbolic form. So the given statement is Q and P. So we may actually also translate this in words. In words, this is actually SPUP is in the city of Ilagan and a Catholic university. Is this given compound statement a true or false statement? So how are we going to actually determine whether it's true or not? So we're going to identify or determine also the truth values of each statement. So let's start with Q. Q is SPUP is in the city of Ilagan. We know that that is false. And P is SPUP is a Catholic university. That is true. Using the truth table for conjunction, so this is conjunction because we have the word and. And for conjunction, if you still remember, a conjunction is true if both statements are true. Are the two statements true? No, one is false. Therefore, the conjunction is false. So this statement, SPUP is in the city of Ilagan and a Catholic university, is a false statement. The truth value of that compound statement is false. Let us have another example, but the given statements are the same. We have P, Q, R, S. So we're going to determine the truth value of the statement, not R or S. So the equivalent statement for this in words is SPUP is not the only private university in Region 2 or an ISO certified institution. So we're going to determine first, okay, the truth value of its statement. Let's start with R. SPUP is the only private university in Region 2. That is actually false. And we have the not R, so the negation of that will be true. And the given statement S is SPUP is an IS certified institution. That is actually true. And then our statement is actually disjunction. We have the word or. So we're going to get T or T. Using the truth table for disjunction, we know that disjunction is actually true if at least one is true. But in this statement, both simple statements are actually true. Therefore, the disjunction is true. And we can conclude that this compounded statement, SPUP is not the only private university in Region 2 or an ISO certified institution, is actually a true compound statement. Another example, we have the statement S if and only if not P. So that is in symbols. And the equivalent statement in words is SPUP is an ISO certified institution if and only if it is not a Catholic university. Is this compound statement true or not? So let's solve it by determining the truth value of its statement or its simple statement. Let's start with S. S is SPUP is an ISO certified institution. We know that this statement is true. NP is SPUP is a Catholic university. That is actually true. And the not P, its negation will be false. So using now the S and P here, T and F, and that's for if and only if. Okay, so is that statement a true or false statement based from the truth table for biconditional? So this one is a biconditional statement because we use the word if and only if. So if one is true and the other is false, what will be the truth value? It is false. So this compound statement, SPUP is an ISO certified institution if and only if it is not a Catholic university is a false statement. Let us have another example. We have the symbolic form, not P or if R then S. So maybe to actually translate it first into a statement or in words, I mean. So we have SPUP is not a Catholic university, or if SPUP is the only private university in Region 2, then SPUP is an ISO certified institution. Is this compound statement true or false? So to solve that or to determine whether it's true or false, we need to actually identify first or determine the truth value of each simple statement. Let's start with P. P is SPUP is a Catholic university, and that is actually true. And its negation will be false. Not P will be false. R is SPUP is the only private university in Region 2. We know that that statement is actually false. And S is SPUP is an IS certified institution. The truth value of this statement is actually true because it's a true statement. And if we're going to get the conditional, R implies S, or if R then S. So we have F then T, false then true. That is actually true if you base it from the table for conditional statements. And taking now the whole statements or symbols here, we have the or. We have here not P, that's actually false, or this is R implies S, that is actually true. So false or true will become true, isn't it? Because that's for disjunction. If at least one is true, the whole or the compounded statement will be true. So this compounded statement is actually true. This table shows the truth value for the different related statements for conditional. That is the converse, inverse, and contrapositive. So as you can see, we have here the conditional, which is actually similar to the contrapositive. And the converse is also same with the inverse. So we can say that conditional statements are actually equivalent to contrapositive statements. And the converse is actually equivalent to the inverse. Okay? So in this activity, we're going to determine whether the two given statements are actually equivalent or not. So let us recall first, okay, which of the four statements are equivalent. Okay, we have actually the conditional, the converse, inverse, and contrapositive. So the conditional is equivalent to contrapositive, and the converse is equivalent to the inverse. So maybe that's the first thing that we're going to determine. Given the first statement, the conditional, we will have to determine whether the second statement is actually inverse, converse, or contrapositive, so that we can actually determine whether the two given statements are actually equivalent or not. Remember, equivalent statements are, we have the conditional and contrapositive. And the other one is converse is equivalent to inverse. So let's try number one. For number one, if a number ends with 5, then the number is divisible by 5. So let's say this is a given conditional statement. And how it is related to the second statement. If a number is divisible by 5, then the number ends with a 5. So that is actually the converse of that given statement. So if the first is conditional and the second is converse, are they equivalent? Yes or no? They are not. Okay, because what is equivalent to conditional is contrapositive, not the converse. How about number two? So if two lines in a plane do not intersect, then the lines are parallel. And then the second statement is if two lines in a plane are not parallel, then the lines intersect. So how is the first statement related to the second statement? Isn't it the first statement is, let's say it's the conditional statement, and the second statement is actually the contrapositive. Therefore, they are equivalent. How about number three? If I live in Pamplona, then I live in Tubigaraw. The second statement is if I do not live in Tubigaraw, then I do not live in Pamplona. How are these two statements related? The first one, let's say it's conditional. The second statement is contrapositive. And since the given is conditional and the other one is contrapositive, we know that they are equivalent, meaning they have the same truth value. Let us now study on how to construct truth tables. Let's say we have the given statement P or not Q. So first thing is we need to have the first two columns for P and Q, and we're going to write the possibilities of their truth values. Okay, so we have true, 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 false, false, true, and both are false. Okay, so since in our given statement we have not Q, so we need to add another column for that that's not Q. So if the given Q here is true, the negation is false. If the Q is false, the negation is true. And if Q is true, the negation is false. And if the given Q is false, the negation is true. And then we proceed to the next connective, that is OR. And then we have actually to we need actually to add another column for the whole statement now, that's P or not Q. So we're going to get, okay, the truth value of this statement using the first column for the P and this third column for not Q. So we have the first true or false, that is actually true because we know that in this junction, if there's at least one true, the disjunction is true. So we have true or true, that will be true. False or false, so both are false, that will be false for disjunction. And then we have false, true, that will be true. And that's how to actually construct the truth table for a given statement. And these are actually the possibilities of the truth values of this statement. Let's have another example on constructing truth table. We have the given statement, not P implies not Q, or it can be read as, if not P, then not Q. So same thing with our first example, we need to write the possibilities of the truth values of the two statements P and Q. So that will be true, 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 false, false, true, and false, false. It's just like a permutation of the truth values of P and Q. And you looking at the given statement, we have not P, so that's why you need to add another column for not P, and we have also a column for not Q, so you have here. So let's try to get first the truth value of not P, that is just the negation of this P here. So if P is true, the not P is actually false. If P is true, so not P is actually false. If P is false, the not P is true. And if P is false, not P is true. And then we also get the truth value of not P. So you refer to this Q here. I'm sorry, not Q. You refer with this column here with your Q and get the negation. If Q is true, the negation is false. If Q is false, the negation is true. And if Q is true, the not Q will be false. And if it's false, the not Q is actually true. And we have now the complete statement, compound statement, not P implies not Q as your last column here. So what we're going to use here will be these columns for not P and not Q, but now we're going to use the conditional because this one is if then or implies, no? And we know that the truth table for implication or what we call conditional is it is only false if we have TF. If false, then true. So in here we have F implies F, that is actually true. F implies T, that's actually true. And then we have now the TF here, that's actually false. And then if both statements here are true, the implication or conditional is actually true. And that's it. That's how to actually construct a truth table. And now it's time for you to actually do it. Try this exercise. Construct the truth table for the statement not P or Q. You may now pause this video and work on this activity in your own study area. Let us check your answers. So for this table, we're going to add two columns that will be for not P, and as you can see here in the given statement, we have already a Q for that column here. And we just have to actually use the last column for our complete statement, not P or Q. So these are now the possibilities, okay, for the truth values of our P and Q. We have T, T, TF, FT, and FF. So we need to get first the not P, that's the negation of this P here. So if P here is true and the not P will be F, false. If this is true, that will be false. And if it's false, the negation will be true. And this is false, the negation is true. And then we're going to get the disjunction of not P or Q. For disjunction, we know that if one is true, the disjunction will be true. So we have F or true, that will be true. We have false or false, both are false, therefore that is actually false. We have true or true, that is actually true. And then we have true or false, that's actually true. So we have T, F, T, T as and the arrangement, if you have the same arrangement and the possibilities. So that's how to construct the truth table for a given statement. I hope you get it. Try this also. How about this example or this exercise here? Construct the truth table for the statement P or Q implies R, or that can be read as P or if Q then R. So what should be the third column here? It can be for R, okay? So it can be for R. So we need to actually, we have three statements now here. So the possibility will be if the first two statements is true, our third statement will be actually true also. So it can be also false here, can be also true here. All can be actually false. Then this can also be false. And then this can be actually true. And then we have here, we can also have here true here. And this can also be actually true. So those are actually the combinations, I mean the permutations for the truth value of the three statements. So there should be eight actually. One, two, three, four, five, six, seven, eight. So we have eight possibilities of the truth values of the three statements. You can actually rearrange this. Okay, so this is not actually definite. You can have different arrangement for this as long as there are actually eight possibilities. Okay, so the first thing is you need to have actually the column for Q implies R, and the last column will be for the complete statement. P or Q implies R. Okay, so we're going to actually use first the conditional statement here, the implication, no? Q implies R. And we know that Q implies R, it's only false if we have true implies false. That's TF. So remember you have to start with Q. See Q here. We have T, T. So T implies T. That's actually true. And then we have T, F already here. That's actually false because we have if T, then false. That will be false. We have false, true. That will be actually true. And then false or implies false. That will be true. Okay. True implies false. That's TF. So it's actually false. False implies true, so that's actually true. And then true implies true, that's true. And then false implies true, that's actually true. And we're not done yet. We have the last column for the complete statement. So we now use the connective or disjunction. So we know that for this junction, if at least one is true, the disjunction is true. So true, that's true. False or false, that's false. Okay, and then we have true or true, that's true. I mean it should be P here. So let's actually try it again, not R, but it should be P. Okay, with this column here, Q implies R, so it should be P here. We need to use this P here. So true or true, that's actually true. True or false, that's actually true. True or true, that's true. And then we have here false or true, that's actually true. False or false, that's actually false. And then we have false or true, that's true. False or true, that's actually true. And then we have true or true, that's actually true. And that's it. We're completed the table. So that's the truth table for this statement. P or if Q, then R. Okay, so we have one more example here. You please try it yourself. So you try to complete the table for this statement. P, if and only if Q and R. So since there are three statements, P, Q, R, P and Q are already were already completed or done for you. And now we have the possibilities for P and Q. Then we need to actually include R here, and then we need to actually include a column for Q and R, and the last column will be for the complete statement. That's P if and only if Q and R. Okay, and then you can have the eight possibilities here. You can rearrange the eight possibilities for PQR. So you may start with all of the statements are true. R is actually false here. And then we can also have true here or false. It can be. So you can actually write false here if you want, or true. Then we have all the statements are false. Then you can also have false, true. This can be actually false. Then this can be actually false, false. Then this should be true. And then false, true. And it should be actually true because we already have the false, true, false. So this should be false, true, true. And then we have true, false, and then true. Okay, so there should be eight distinct possibilities here. Okay, you can actually rearrange all of these possibilities. Now you need to actually do the conjunction of Q and R. So you have here Q and R. It's only true for conjunction if both statements are true. So we have true and true. That's actually true. True and false, that is actually false. False and false is actually false. False and false is false. True and false is actually false. And then we have false and true, that's actually false. True and true is actually true, and false and true is actually false. That's for disjunction. Then we have now the biconditional. You know that For biconditional, it's only true if both are false or if both are true. Okay, so we have to use P and this fourth column here for Q and R. So remember, you need to use P here. So P if and only if Q and R, that's true. If and only if true, that's actually true. Remember, biconditional is only true if both are false or if both are true. So true if and only if false, that's actually false. True if and only if false, that's false. We have false if and only if false, that's actually true. Then false if and only if false, that's false. And then we have false if and only if false, it's also false. Then false if and only if true, that's actually um, false. Okay, and then in here, I'm sorry, these two here should be true here, and this should be actually true also because both are false. Okay, and then we have true if and only if false is actually false. Okay, so you can actually check this one, and then you may comment if you have some mistakes here, or you can actually share it later in our synchronous session. And that's all for our truth tables for this example. Hello, so I hope you find the lesson interesting. Okay, even it's challenging, it's actually fulfilling if you actually completed a truth table. Okay, and that's all for logic, and congratulations, you're done with module 2. Thank you. See you in our midterm.